Hi everybody, welcome back. Let's continue our telecom journey. The syllabus is IPN companion protocol, IPv4 header, IP networking, and IPv4 classful addressing. So let's start with the IP networking, IP and companion protocols. So internet protocol, as we know that it is a host to host protocol, host to host based protocol. Best effort delivery protocol is basically IP protocol fragments TCP UDP segment and encapsulate IP address as well as other fields to form IP packet, complete IP packet. And IPv4 headers, we have 20 bytes nominal that contains source and destination IP address, 32-bit each, and version is their length service, and we have already discussed this thing in previous video. So basically, there are some other companion protocols which are Internet Control Message Protocol, that is ICMP. Then we have Internet Group Management Protocol, IGMP. Then we have IGP and EGP routing protocol, Inter Gateway Protocol, and External Gateway Protocol. Then we have Address Assignment Protocol, RARP, and DHCP, Dynamic Host Control Protocol. So these are the some IPN and their companion protocols that are very efficient, and they work as per in coordination with the IP protocol. Let's have a look over this IPv4 header, and we have already discussed this thing that it has 32-bit, that is almost 4 byte, and it has version. Then it has length, IT length is there. There is a, and then we have identification flag, source address, destination address, and other options and paddings are there, similar to other UDP and TCP protocol. So we talk about the IPv4 addressing. It has each host assigned to a 32-bit IP address, and each address is a pair of net ID, that is network ID, and host ID, depends on the class of addressing. So dot decimal notation. So in this notation, IP address written as 4 dotted decimal integers. So we can see in this example 128.10.2. And 30. These are in decimal integers. Then we have DNS, domain name spacing, converts number address to the letter address, which basically means if you type google.com, it doesn't mean that you're typing the google.com, you're typing a specific IP of that Google, but basically that IP is converted into DNS, that is domain namespace, and we have to remember this, easily remember by all of us. That's why we use DNS instead of using this IP, because if we have to remember the IP address, we can't remember so many IPs. So instead of that, we use DNS for a particular IP. And if we talk about IPv6 addressing, instead of 32-bit IP address, it has 128-bit IP address, which is in hexadecimal colon notation, not in decimal way. So basically, the classification of addressing in such a way, each class is divided into 4 octets, as we already discussed. And in class A, the octet 1 is network ID, and rest of the 3 octet are for host ID. And the first octet value always be there for 0 to 127, right? And for class B, we have octet 1 as for network, and for octet 2 also for networks. For rest of the 3 and 4 are for host. So basically these octet 1 and octet 2 having the value ranging between 128 to 191 if we add in decimal. For class C, then network is for octet 1, 2 and 3, and octet 4 is for host. So in this way, these are classified. For class D and class E, they are multicast and reserved. So no such host address and network address concept is there. So basically the range are in 2242, 239 for D, and for E 242, 255. This is very important slide, yet you have to remember that for which octet it's for network, and for which octet it's for host, for which class. So you can easily remember this, it's not a big deal. Now we talk about the IPv4 address management. We have subnetting, that divides the large network into small chunk called subnet. So basically the purpose of subnetting is to reduce size of the broadcast domain, and subnet derived from the borrowing ones from host ID to subnet ID. Basically we are driving or borrowing number of ones from the host ID and transferring it to subnet ID, so that the subnet can be increased.
So if we talk about the private addressing, basically these are the block within the domain reused and network address translator router proxy server converts into public address.
And in class A we have the IP series 10.0.0.0 to 10.255.255.255 in network 1. And if we talk about the class B, we have 172.16.0.0 to 172.31.255.255, and we have 16 contiguous networks. And in class C we have 192.168.0.0, 192.168.255.255, and it has 256 contiguous networks.
I hope you like this video. It's a quick recap of the IP and subnetting and networking. A quick snap of networking and how the classes works and what are the range of the IP address in all this network. What are the network ID and host ID. And simply listed. Thanks a lot and keep watching this video for a better understanding of telecom domain.